Today I am Tanish and going to upload my first video on coding. This video is basically about plane detection in ARKit and to start a brand new course how to build a ARsolar system. Let's start coding. Whatever you want. Team as your team. Organization you can get not anything. Language make sure it is Swift. And content technology SceneKit because we are using 3D objects. Next. Create a new project on the location where you want to save. Open arts.scn assets. Just thresh this or delete it. Move to thresh because this space takes your space. Open view controller, remove the sample name and all that because it's just not of use. As we are doing plane detection, we need some universal variables. SCN plane with a one bar. Okay. Now let just solve that mistake. We just do not need. Let anchors array is equal to empty array because we need some anchors in the array as they are anchors because we are working in an argumented reality set. Go to configurations, enable plane detection, horizontal, configuration dot light estimation, true, to make it that our content is light estimated according to the lights. Now another universal variable and some corrections, just make it like this. And here a let plane identifier is equal to UUIG identifier, make it's all in uppercase and then close it. Now find a rendering func which Apple has made for us. Just uncomment it, open it, create a new plane object, but make sure it is with if let plane is equal to anchors, wrap it, unwrap it as AR plane anchor, then do it. Now here we have to write the func. We have created our plane object. Now change the properties. Node is equal to SCN node plane geo dot plane geo is equal to, just declare it as SCN plane with some properties, width and height. CG float, here it is X, here CG float, and Z axis. Plane dot extend dot X axis, plane dot extend dot Z axis, as the Z is the original height, outermost. Make sure you fix it. There are some errors which They have not universally declared node, so we have to declare it universally. Make it a semicolon and here like this. Good. Now after that, again some editing with plain geo dot material dot diffuse dot contents, give a color UI color dot white dot, make it a translucent one color so you can feel that plane and get original height. Make the alpha as 0.5 as transparency. Then change the plane node. Create a plane node. New plane node is equal to the SCN node with a geometrical object which we have just created as plane geometry. Then edit this plane node with, give it a position. The position is SCN vector 3. X will be plane anchor dot center dot x. We have created plane dot center dot x, and the y will be plane dot center dot y, and here it is the final axis, z axis, plane dot center dot c axis. Here we have created or given the position to the original object, the plane. Here just remove this plane dot center dot y and keep it 0, as 2D objects never have y value or have, but here just add a s and change it to var. Make sure it is var to add a new object. Here we can add anchor survey dot append a new element, the plane anchor we have created. Now this part is over. This is creating a rendering function which finds a plane, places a new SCN plane, and executes. Now we have to add a did update function. Update. Yeah, that one. Here, create a new variable, plane anchor as anchor as again an AR anchor. Make sure it's AR plane anchor, as we are working in ARKit. Everything should be AR, augmented reality. This is a nesting code because we are continuously using successions of if. Now finding the anchor in that anchor array, that if it contains that anchor which we added by checking a plane again. Okay, just unwrap this as we are using it for AR anchor. Thank you. Here, by unwrapping this as with a question mark sign, then continue our nesting code or succession code. It's better if we speak succession code. Node dot child node, we are checking that its a child nodes count is greater than 0 or not. If it's greater than 0, then we have to create a new plane node is equal to node dot child node that we have created dot first to not repeat the code. This coders do for saving their time efficiency. Now give this plain node to a position. Again an scn vector 3 variable with x position denoting plain enter dot center dot x y position to the same plain enter dot not this time we are not giving him it a z position as it's already listed and it is a 2D plane with very low thickness, so we are directly skipping it to z axis. Here we can give plane enter dot center dot z position as it is an 2D plane are general 2D, but we are using it in 3D. Now create a new function for updating the material. Let material is equal to self dot plain geo dot materials dot first material that we have created, the white alpha. Use this material, diffuse, transform it with scn matrix 4 make scale. Here we are using a float. Make sure that it's not a CG float, it's a float, just a float, because it supports a float. Plain geo dot width that we have created here, also a float. Plain geo dot most likely height, and z axis we are getting it of 1 value to denote it. Yeah, it's okay. Now just correct this spelling. Float, yes, most of coders make mistake in spelling as their spelling is not good. At last and the final if let statement is for plain node dot geometry as an unwrapped scn plane to give its width and height, but make sure this is last and after it you are easily accessible to make sure it's a CG float. Do not change it to a float because most of coders make this mistake. ARanchor dot extend dot x and in plain dot width we give a CG float dot just bracket it plain enter dot extend dot y, not y, z position z axis. As I told, it's a 2D object. Now add the update material which we made. Here it is, it's getting its height, change it to height, width and the material. When these three things combine we can make a app. Now at last finally we have to just transform this plane and make it rotate. Plane node dot transform scn matrix 4, make scale rotate, the angle will be half the pi. Cg float dot pi half, x value will be 2, y 0, zx is 0. That's it. Now we have to run this. Wait, and last error and count this. Yes. Sorry, it should be a float. It's my misunderstanding. Change it to float. Finally, run this code. Run this code by choosing a physical device which is having a chip greater than A9X chip, because here it supports only A9X or higher, which means 6S or higher. Test it. It will 100% detect the planes on an horizontal level. Here is the app. Now find a plane. And that's it. How we are finding our plane. It's so accurate that each edge we can find. Thank you for watching my video, and please do not forget to subscribe it.